And today we're going to study about this conversion of flip-flops. Before going to this conversion of flip-flops, we have studied about four type of flip-flops last classes. One is your SR, one is your JK, one is your D, and one is your T. And for all those flip-flops, we have tried to understand how it is working. We have also tried to find out its truth table and its characteristic table, its excitation table, and we have solved the K-maps and try to find out the equations for all these things. Now we are going to solve how the flip-flops can be converted from one flip-flop to another flip-flop. For that one, we can take an example and we can briefly understood how it is actually working and how can we convert that one with a step-by-step procedure that we are going to see. So let's see conversion of JK flip-flop to D flip-flop. So what is the requirement over here? The first requirement you can see is that what is the available flip-flop present with us. So in the short we can say the available flip-flop is your JK. And what is the target flip-flop for us? The target flip-flop is your D. So what we can say is that our target flip-flop is your D. So when I studied about your JK flip-flop, we have constructed this JK flip-flop by the help of your NAND gates, and to have this JK flip-flop's truth table, we have taken the reference truth table of your SR flip-flop, and to have this truth table of characteristic table of JK flip-flop, we have used your truth table of JK flip-flop. To have the excitation table of JK flip-flop, we have gone through the reference of your characteristic truth table of JK flip-flop. So here when we are seeing about this conversion from JK to D, so what we have done is that we have directly written the excitation table. This excitation table we have derived from the characteristic table of your JK flip-flop, and the excitation table and the characteristic table is being drawn from your truth table of your JK flip-flop. At the same time, what is the available flip-flop with us is that your JK flip-flop, and what is the target flip-flop for us is that the D flip-flop. So what is the first procedure that we have to follow is that to find out which one is available and which one is the target flip-flop. Okay, the available flip-flop over here is JK and the target flip-flop here is D. And we have written the excitation table of JK flip-flop here for the reference. And when we are seeing the JK flip-flop excitation table, this one Q1 is your present state, Q1 plus 1 we have governed as your future state. So with these two states, four possibilities are there. So it is 0, 0, 0, 1, 1, 0 and 1, 1. And the excitation table when we are seeing at the output for the J and K, we can see for the 0, 0 of present state and next state, your J value is going to 0 and for K this one is don't care. From 0 and 1 as Qn and Qn plus 1, your J stands 1 and your K is again don't care. For 1 and 0 as present state and the next state, you will having your J is don't care and 1. And Qn plus 1 is 1, 1. You can see your JK value is don't care again 0. And after completing this one, what we have to do, we have to again try to find out the characteristic table of D. We have also derived the characteristic table of D from the truth table of your D, and the truth table of your D has been referred from your truth table of your SR table. So if you are going to find out the characteristic table, if you are going to see that one, then what I have written over here is the present state, the input D, and the next state Qn plus 1. So here you can see that we have also derived from the characteristic table of D that you can directly write down over here as Qn plus 1 is equal to D. That the equation of Qn plus 1 equal to D that you have already derived in the characteristic table of D flip-flop when I have started about D flip-flop. So here we are going to say with the possibility of Qn and D, the present state and the input D, four possibilities can be there up to 0, 0, 0, 1, 1, 0, 1, 1. And from this equation of the characteristic table that we have already found out, directly you can write out over here as Qn plus 1 directly leading the value of D. So D is directly representing at the Qn plus 1. So 0, 0 it is 0, 0, 1 this one is 1. 1, 0 again we are going for the 0 and again 1, 1 is 1. So these are two steps. The first one is that you have to write the excitation table for the available flip flop, and the second one is that you have to write the characteristic table for your target flip flop. After that, now we are going to do the conversion one. How we are going to do this one? Now, what we have to convert is that a JK flip flop has to be converted to D. So we have tried to find out the values of J and K by the help of this characteristic table, which are derived with D from its present state and the next state of D. So what I am writing over here is that, again I am writing this one J and this one is K. I am trying to find out the value of J and K, referring to the excitation table of J and K, and with the characteristic table to this present state and future state Q1 plus 1. So when Q and Q1 plus 1, these two things are responsible to find out the value of J and K. When you are converting your JK to D flip flop, we can see that when this Q1 present state and Q1 plus 1 is your 0 0. So we can again refer over here is that when Qn and Qn plus 1 is 0 0, we are writing for J as this one is 0 and this one is don't care. So directly you can write this one is 0 and this one is don't care. Okay. So again when this value you can see as 0 and 1, Qn and Qn plus 1 0 and 1. Again referring to this excitation table, you can see 0 and 1 is going to give the value J as 1 and K as don't care. So this one is 1 and this one is don't care. Again at the same time, the Qn value is 1, Qn plus 1 is 0. Qn value is 1, Qn plus 1 is 0. The excitation table tells that J value is going to don't care and your K value is going to 1 and 1 and this 1. So you can see Qn value is 1 and Qn plus 1 is 1 in the characteristic table of D, and you will refer to this excitation table as 1 and 1. So J having the value of don't care and K will take the value of 0. So up to this we can understand is that, so a characteristic table for the targeted flip flop has been written from the equation, and from that one we are trying to find out the value of J and K in terms of your Qn and Qn plus 1 that is being present in the characteristic table of D. Okay. So the next step is that we have to find out the circuitry diagram for the J will have and what the K will have. For that one, again what you can do the K map. So we are going to have the K map over here for J. When we are targeting J to find out the circuitry diagram and we are designing the K map, you can see this one is a 4 variable K map. And here many of the students being wrong, being taking this characteristic table as Qn and Qn plus 1 as because they are thinking this J value has been taken with reference to this Qn and Qn plus 1 and reference to the excitation table of this one. But what the problem with this is that we are trying to convert this JK as to D. So here the input is nothing the Qn and Qn plus 1, rather than this input is Qn and D. So here we are taking Qn and D. This one is the K map. So when I am mapping the K map, you can see that this 0 0 is going the value with the J as 0. So this one is 0. 0 1 is going to give the value as 1. So this one is 1. 1 and 0 is going to value of don't care. So 1 and 0 is giving you don't care. Again 1 and 1 is also giving the value of don't care. So this one is also don't care. So this one is a K map that are designed for taking the input as Qn and D and the characteristic table for the input of J. So here this one is the loop that you can say can only loop possible over here. For this loop, if you want to write, you can write your J is directly equal to D. This equation you can see this value is 1. So for the value of D, D values remain constant for both of the terms, and we will go into the Qn. Qn is actually changing its value from 0 to 1. So directly this loop value you can say J equal to D. And the same possibility with the same thing we can try to find out the equation for K. So again, if you take the equation for k, again with two variables q, n, and d, so you can see now taking the inputs as q, n, and d. So we are trying to find out what should be the k. Again, if we can write directly, this one is don't care, this one is don't care, and again these two terms are don't care for 0 0, from 0 0 this one is don't care, for 0 1 again this one is don't care, for 1 0 this one is again 1, and for 1 1 this one is 0. Okay, again in this k map, again a single loop can be possible over here by taking this 1 and don't care. So here you can also see that Qn is changing its value from 0 to 1, so this you cannot take, as d value is constant for this both the outputs over here. So d value again we can write as, because this one is 0, so we can write k is equal to d bar. Okay, so we have already designed the equation j equal to d and k equal to d bar, so you can write it over here as j equal to d and k equal to d bar. Now these equations are important, these two equations are important for us to design the JK flip-flop or to convert the JK flip-flop again to D. Now you can see, we can directly draw the circuit diagram over here, that the input is J and K and your output is Qn and Qn plus 1. At the same time, this one is J, this one is K, and having a clock, this one is clock. Now, the important term over here that we have to introduce by the help of these two equations is that the input now will be D. The single input will be D. So we can write the single input is D. Now J is equal to D. So this D is directly connected to J. So this equation 1 is satisfying over here, being connecting D directly to J. And now this K will be the inverted version of this D. So what we can write over here is that we can take one NOT gate. This one is a NOT gate. By the help of this NOT gate, we can again give this the input of D to K as D bar. So this one is a JK flip-flop which has been successfully converted to a D flip-flop. In the next class, we'll try to solve some other flip-flops conversion. So this was for this time. Thank you.